In this tutorial, I'm going to show you the last kind of related rate that we're going to look at least for this week. And it is the kind that's on example 5 on page 152, and this is a changing angle of elevation. So we're just going to call this angle of elevation. And we have a rocket. So I'm going to go and draw a picture. This is also dealing with right triangles, but in a different aspect this time. So my rocket is up here. Okay. There's my rocket. And this is a camera down here, and it's taking a picture of the rocket. And then I have my liftoff station here. So this is my liftoff station. And this is creating a right angle right here. Now this problem gives me some information. I'm going to label it in my picture. And it says find the rate of change in the angle of elevation of the camera as shown at 10 seconds after liftoff. And in my picture, I am told that this right here is theta. And the camera is 2,000 feet away from the lift station. And then I know that this is S. So that just stands for the distance from the rocket from the ground. Let me do that S again. It's bothering me. Okay. So we're going to do our list. We're going to list out our known, what we're trying to find, and of course our related rate. Alright, so once again the problem says find the rate of change in the angle of elevation. Now since we're dealing with an angle, we're going to call this d theta, dt. And, oops, that's what I'm trying to find. I put it in the wrong spot. Hang on. Alright, so d theta dt. And it says I'm 10 seconds after liftoff. So I know that this is at 10 seconds. Okay, so what am I trying to find? And what is the related rate? If I'm trying to find the rate of change in the angle of elevation, see if you can think about that for a second. And something else to consider is below this picture there's some more information about this S, the distance from the liftoff station to my rocket. And that is that it is equal to 50t squared. That's very helpful information. And I forgot that that information was even there below the picture, but we're not going to be able to get very far without it. So in order to find what S is, and we know that this is 10 seconds, well, I'm just going to substitute 10 in for t and see if we can solve this. And actually we're not going to solve it yet because remember that I need to know some more variables and some more rates. Think about what the derivative of this would be. What would I get if I did ds dt? And the answer to that question is, well, I would have 100t. Okay? Because remember that this is not a set, or at least this equation does not represent a set time. It represents how, at whatever time that you're talking about, the distance it is from the liftoff station. That specifies a rate. So the rate is what we are interested in. Okay, this is the velocity of the rocket. It's how fast it's moving. And it's going to move all the time. It's going to continue to increase. So using this information here, I now have another piece of information I can use. Okay. So how am I supposed to use this information to help me solve for d theta? Well, we have to have some kind of relationship. And the relationship in this case is using our Sohcahtoa rules. So if you don't remember, it was So, Ka, and toa. So in relation to this theta, I know the opposite side and I know the adjacent side. So opposite and adjacent is tangent. So that's what we want to do. And I'm going to list that under my known as well, because I get to use that information now that I know what it is. So tangent theta, oh, but actually I'm going to put this under my related rate because this is how we're going to find that theta. So tangent theta equals that S over 2,000. And remember that S is the same thing as that equation, and that's fine, but we'll get to that in just a second. So I think I've got quite a bit of information here, so we're going to go ahead and start deriving. So the derivative of tangent theta is secant squared theta. So secant squared theta, and I need to add a d theta dt. And so far, so good. I know what d theta, this is what I'm trying to find, okay, and I can solve for any unknown theta by using inverse. So far we're good. Now, as far as S over 2,000 goes, don't think quotient rule yet. I want to show you a different way to write this, because this is the same thing as 1 over 2,000 times S. So this is just a coefficient, this 1 over 2,000. So 1 over 2,000, I'm going to keep that right there. The derivative of S would just be 1, but I have to add on a ds dt. So hopefully you see that it was actually very, very nice that I went ahead and found out what that ds dt was already. And of course, if you didn't know to do that beforehand, you would know to do it now. Okay, so let's go ahead and try to get theta as isolated as possible. So I know that secant squared theta and then d theta dt is equal to, and then ds dt was 100t, so I'm going to write that in my numerator, just like so. And then what am I going to do for theta? How do I know what to do there? Okay, so I want to point out that my gut instinct would be to divide both sides by secant theta, or secant squared theta, which is the same exact thing as me multiplying it by 1 over secant squared theta, right? So those are going to actually cancel each other out. And think about what 1 over secant squared theta might be the same exact thing as. See if you remember your reciprocal trig. And if not, I'm going to help you out, but that is the same exact thing as cosine squared theta, which is way easier to deal with. So once again, how do I use that cosine and the theta to help me out? Well, just by looking at my picture, I may not even need to know what theta is, as long as I know the relationship for cosine. So look back up here in my picture and look at the cosine statement. It's adjacent over hypotenuse, which right now the adjacent part is 2,000. Okay, so then what would the hypotenuse be? Well, this is where some of this information is going to come in very, very handy. So this S over here is equal to 50t squared. And right now I know that t is 10, so 10 squared is 100. 100 times 50 is 5,000. Now, knowing this information, could I determine the hypotenuse of this triangle? And the answer is, of course we can. So what we're going to get is, this is going to be the way that I get this right here is I'm going to do 2,000 squared plus 5,000 squared. And that's going to give me this, and then I'm going to square root it. And let's see what that gets me. And I'm actually going to leave it as the square root of 2,000 squared plus 5,000 squared, and you'll see why in just a second. Alright, so this is just so that I can substitute that in here for cosine. Okay, so we are almost finished with this problem, and I'm going to say that d theta dt equals 100 times t, which we know right now to be 10. I'm going to go ahead and substitute that in there, all over 2,000 times, and this is where I'm going to put the square root business, which is the square root of 2,000 squared plus 5,000 squared, and this whole thing is squared. So that's why I left it under a radical, because the square root and the square are going to cancel each other out. And when we calculate all of this out, and I forgot to do something, and I did it kind of silly. Hang on a second. I need to erase this before we finish up. I did not write this right, because cosine was the adjacent side, which is 2,000, and that is over the square root of 2,000 squared plus 5,000 squared, all squared. I apologize about that. So from here on out, we have all the information that we need. So this is just a matter of calculating and then adding on your units at the end. So as you can see, some of these problems are going to get pretty crazy. Just keep yourself as organized as you can and check your answers in the back. And that concludes this tutorial.